This is 7.5, and it's going to be using what's called conditional probability. So in conditional probability, you find the probability that something is going to happen if you know that something else has already happened. For instance, if I roll a dice and say, what's the probability that the answer is going to be a 6? What's the chance of getting a 6? 1 out of 6. Okay. What if I roll a dice and I look at it, I don't show it to you, and I say, oh, it came up even. What's the probability that it's a 6? 1 out of 3. That is called conditional probability. So what is the probability of getting a 6 if you know that the answer is already even? And we call that a given. So I would say, what is the probability of 6 given even? So we know that even has already happened. 1 out of 3 even numbers is a 6. Does that make sense? Okay. So a dartboard has 8 equally sized slices, numbered 1 through 8. Some are white, some are gray, etc. A dart will be tossed and will land on a slice at random. What is the probability of getting a gray slice? I don't know if you guys can see that. Can you see the gray? So how many are gray? 4 out of, there are 8 total, so 4 out of 8 is 1/2. So what is the probability? Oh, hold on a second. What is the probability of getting gray? That would be 1 out of 2. What is the probability that the dart lands on gray, given that the dart lands on an even numbered slice? So how many evens are there? 1, 2, 3, 4. So we know that the result is even. What's the probability that it's an 8? 1 out of 4. And here we would write, what is the probability of gray? And down here we would write, what is the probability of gray given, and we do that with this single vertical line, given even. Okay. Let's do another one. Okay. What is the probability that the wheel stops on white? 5 out of 8. What is the probability that the wheel stops on white, given that the wheel stops on a number less than 7? So I'm going to circle all the numbers less than 7. Does 7 count? Is 7 less than 7? No. So we're only looking at this group. What's the probability that we get white given a number less than 7? 4 out of 6, which is 2/3. So the probability of white is 5 out of 8, but the probability of white given the answer is less than 7 is 2/3. Does that make sense? Do you need to see another one of those? One more? Okay. What is the probability of drawing white? So that would be 5 out of 8. What is the probability of white given that the number is less than 7? So again, I'm only looking at these. That would be 4 out of 6, which is 2/3. Now, in the next lesson, we're going to be comparing these two numbers. And we're going to ask, does the chance of drawing a white depend on the number of the card? And what we're going to ask in the next lesson is, are color and number independent? Do they depend on each other? So in this case, is the probability of drawing a white the same of the probability of drawing a white if you look at numbers less than 7? Yeah, they're different. They're totally different. Sometimes that's not the case. And that's going to be the next lesson. We're going to talk about independence and dependence. So you don't have to worry about that today. Oh, no. I was thinking of the other class. We are worried about that today. A spinner has 10 equally sized sections. 2 are gray, 8 are blue. The spinner is spun twice. What is the probability that the first spin lands on blue and the second spin lands on gray? So we want blue and then we want gray. What's the chance that we get a blue on the first spin? Well, 8 out of 10, which simplifies down to 1 over 5. Okay. Now, does getting a blue on the first spin affect the outcome on the second spin? What do you think? Does the first spin affect the second spin? No. Those spins are completely independent, right? If we roll a dice once and we get a 7, or can't get that, get a 6, does that change the chance of getting a 6 on the second roll? No. So those would be considered independent. Now, what if I were picking names out of a hat? So I reach into a hat and I pull Tice's name out and I set it down. Does that change the chance of getting Tice on the second draw? Yeah, because he's no longer in the hat. That would be called dependent. Okay? All right. So what is the probability of getting a gray on the second spin? Oh, hey, why didn't you guys correct me? 8 out of 10 is 4/5. And what's the chance of getting gray on the second spin? 2 out of 10, which is 1/5. So what's the probability of getting blue and then gray? We multiply them together. So we times the tops. 4 times 1 is 4. Bottoms, 5 times 5 is 25. Okay, let's do another one. A box contains 5 pencils and 5 pens. A second box contains 9 colored pencils and 1 crayon. One item from each box is chosen at random. What is the probability that a plain pencil from the first box and a colored pencil from the second are selected? So the first draw, we want a pencil, which is going to be 5 out of 10, or 1/2. And the second one, we want a colored pencil, which is going to be 9 out of 10. We multiply those together. 1 times 9 is 9, and 2 times 10 is 20. So the probability is 9 out of 20. So in general, when you see the word and, it means multiply. If you see the word or, it means add. And in probability means multiply, and or means add. Okay? Oh, that's not what I wanted to do. Okay. A bag contains 10 marbles. 2 are green, 5 are red, 3 are blue. Keith chooses a marble at random and without putting it back chooses another marble at random. What is the probability that he chooses red and then red? Well, what is the probability of choosing red on the first marble? That would be 5 out of 10, which is 1/2. And then I don't put it back in. So I draw out the red marble and I set it down. What about the second draw? What's the chance of getting a red? Well, how many red marbles are left? 4. And how many total marbles are left? 9. So this one is 4 out of 9. And because it's an red and red, we multiply. And we get 4 over 18, which simplifies down to 2 over 9. Does that make sense? Do you want to see another one? No comment? Do you need to see another one? No? Okay. Of the people who fished at Clearwater Park today, 54 had licenses and 36 did not. Oh, the lawbreakers. Of the people who fished at Mountain View Park today, 72 had licenses and 8 did not. What is the probability that we choose a non-licensed person and then a licensed person? So this is Clearwater and this is Mountain View. So 54 and 36 add up to 90. And 72 and 8 add up to 80. So what is the chance of getting a non-licensed person from the first group? That would be 36 over 54. And what is the probability of getting a licensed person on the second group? That would be 72 out of 80. And it's an and. So we multiply. So 36 out of 54 times 72 out of 80. And I get 0.6. So we have a 60% chance of that happening. An automobile manufacturing plant produces 36 vehicles. 17 are sedans, 5 are vans, and 14 were motorcycles. Each falls into only one of these categories. So you don't have any vans that are motorcycles, apparently. Plant managers are going to select 2 of these vehicles for a thorough inspection. The first vehicle will be selected at random, and the second vehicle will be selected at random from the remaining vehicles. What is the probability that the first is a van and the second is a motorcycle? So, what is the probability of getting a van? That would be 5 out of 36. Okay. When we draw a second time, are we going to put that van back in the hat? No. Okay. So what is the chance that this is a motorcycle? Well, there are 14 motorcycles. And how many are there to choose from? 35. Good. So we would multiply that together. What if on the first draw you don't get a van? Then what do we do? We lose. We're out. So we're only worrying about what's the chance of winning and then winning. If you lose on the first one, you're out and you don't continue. So when we do this calculation, we put in what is the chance of winning here and what is the chance of winning here. And then you just multiply those together. Okay. Oh, this one shouldn't be on there. So, get to work.